Hello kittens, welcome back. This is Seb the Cat. Today is Friday, and on Fridays we don't actually have a particular schedule. So the coolest thing I've been working on this week is our new game, Drifter. Drifter is a space puzzle game. We've just been focusing on the single player movement and shooting mechanics, and then probably next week we'll start integrating the multiplayer. And then for anyone who's interested, that will be going up online for people to play. But today I think I will focus on the bullet collisions, the feedback, the player's health total, and maybe a little bit of effects. Yesterday was a fantastic stream. Thank you for everyone that followed. Don't forget to ask questions in the chat if you need any clarification. There is a Discord channel if you are a developer yourself and want a community for getting help on side projects and things. YouTube channel for stream highlights, and Twitter if you want to be notified when we go live. Okay, without further ado, let's jump over to our editor and have a look at the Godot project, where we are right now, and then we can get started. So, yesterday we had most of the enemy AI programmed. However, there was some issue I had with the mathematics behind the, following the player. And it turns out I was just using the wrong API in Godot. So once we have a look at the game, I'll run you guys through what I did this morning to fix that issue. It was relatively simple. Okay, so what we've got now is we've got an arena full of enemies, and they're starting to shoot me already. Jesus Christ. Okay. I've made them quite aggressive. Okay, so essentially we are a spaceship. We've got forward thrusters and backwards thrusters. We can spin, and then we can pick up these little bubbles, and the bubbles represent both our health and our ammunition. Okay, so as I pick up the bubbles, they will just add to my tail, and the enemies are really just having a go at me. As you can see, the bullets are not dying, and that is one of the reasons why we're focusing on that later on today. I want to have some cool particle effects when they collide. Okay, so the way that these enemies work, I think their sight is maybe a little bit too big, so we might have to tweak that slightly. So the way these enemies work is they have sort of an area around them, mainly in front of them, where they are essentially aware of the player. But once you get outside that area, then you essentially lose their interest. So I guess the problem is that the larger your tail becomes, they treat your tail as if it's you, right? So if they can see your tail, then they can see you, and they will shoot both at you and at the tail, right? So essentially, the further you progress in the game in any one round, and this will be the same in multiplayer, the further you progress, the harder it is to avoid being shot. But you can shoot letters off your tail, and you can see here we can slowly shoot enemies using letters of the tail. And that's the basic mechanic there. I can just scoop up all these old bullets like a snowplow. Then the other mechanic I think that we're going to implement is essentially like a puzzle mechanic. So the aim of the game will be depending on the round. So it'll be sort of like an arena game, and the aim of each round will be to collect certain letters to spell the answer to questions or to spell certain words. So you're going to have to manipulate your tail in a way that you retain the letters you want and you get rid of the letters you don't want. Yeah, okay. So that's sort of where we are right now. I think the biggest issue with the game is the enemy bullets are not dying. So we're going to have a look at that. But before I do that, I just want to run through what I did off stream this morning, just to get that that player tracking up to scratch, because we were having a little bit of a problem with the mathematics last night. So I think what I'm going to do first of all is I'm just going to bring that site down a little bit. Maybe bring that down to like a 400, and maybe make it a little bit wider. So like what's a 400 look like? Maybe. Yeah, I think that's probably a little bit more realistic. Okay, so what I did to get the AI following the player in a semi-realistic manner is I created an area 2D, and I've called that site, right? So that area 2D represents the site of the enemy, and it's just got a collision shape, which is this capsule shape, which defines when does the player enter the sight line. Okay, and obviously I have all of the objects in the enemy set up as before. There's actually not a lot of difference there. So what I do is on ready, I create a reference to the site node, as you normally do in Godot. I've got a goal variable attribute, and it starts off at null, so the enemies have no goal at the beginning. Then on our ready function, I connect the site's body entered and body exited events to handlers on this object, and the handlers are exceptionally simple. What happens is when a body enters their site, they set it as their goal, and when a body leaves their site, they nullify their goal. Really, really simple, right? And then what happens is when we come to integrate the forces, which is essentially how we process the physics of the game, we basically say, if there's a goal, chase it, and then proceed with the rest of the logic. Now, the chase is saying that, in fact, I'm not sure whether engines ever need to be turned off in this scenario. So the chase, we're basically, this is the code which we struggled with. I was using, can't remember what I was using. I wasn't using direction 2, and that was my problem. Okay, so what happens is when we want to chase the goal, we take our current position and we work out the direction to the goal's position, right? And that's going to give us a vector 2. We then call dot angle on the vector 2, and we add half pi, right? So that's 90 degrees. So that gives us essentially the direction that if we were to point directly at the player, that's where we would point. Okay? Then we don't want to just point straight at the player. That's not realistic. We need to actually rotate a little bit. So what we do is we're going to apply an impulse. And the impulse is going to be equal to our current rotation minus our desired rotation. And then we just apply our negative spin. How much? This is the spin impulse is how much power does the enemy have when it wants to spin? When it wants to turn a corner, how much torque does it have? So that's what we apply there, and that's going to give us a little torque impulse to be able to rotate the enemy in the desired direction. Now the last little piece, the cherry on the top, is this lerp angle function. Now this stands for linear interpolate angle. Now normally if we just took one angle and subtracted it, if there was an overlap between, let's say, 359 degrees moving to 10 degrees, you would get like a full spin all the way around, when in reality you just want to go 11 degrees, right? So this function here handles that loop around when it comes to angles, so we use that. And then essentially that will give us the ability to, if the player is in our sight, just steer towards them, right? And you know, I'm going to add that as a comment here to make it obvious. So we can say steer towards wherever our goal is. Okay. Now there's one more thing I want to implement here, okay, is right now, if the enemy has the player immediately in front of them, they're going to shoot at the player. However, sometimes the enemy has a wall in front of them, and that's not really what we want. We don't want them to just shoot a wall aimlessly. So let's have a look and see how this enemy is set up. So I'm going to hide this because it's not important right now. And let's have a look. If we hide the origin, we can see a little bit more what's happening here for the enemy. So the enemy has the enemy has 4 navigation rays. Okay, we got right, left, back, and forward. So left and right are on the sort of the periphery, on the wings, and those navigation rays are scanning to say, is one of my wings gonna bang into a wall in the near future? And if so, I should probably turn on that engine and spin away. And then the back navigation ray says if I'm getting stuck, I should probably reverse. But if there's something immediately behind me, I don't want to reverse because I'm just going to bang into that instead. And then finally, we've got this forward navigation ray. And this is not really to do with navigation, but I've called it that anyway. It's mainly to do with if I shot right now, would I hit the player? Okay, so that's essentially how we're using it. So the problem is that the player is setting off that navigation ray, but we also want the environment to set it off as well. So if I open up this navigation ray, I can see that this is interested in players, not much else, and player chain. And I think we're going to need to turn on the environment. So now that means this navigation ray will... Sorry, I need a drink. Talking too much. Okay, so this navigation ray will collide with the player or the environment, right? And that will allow us to make some judgments going forward.